Triangle proportionality. So if you have a line that is parallel to one side of a triangle and intersects the other two, then it divides the sides into segments that are of proportional lengths. So if we look at this triangle here, we have DE that is parallel to AC. Isn't necessarily the midpoint, we have no idea where it is, it just happens to be parallel to one side of our triangle. Now, if we were to write a proportion for this, because it says it divides it into proportional lengths, one of them can be that AD over DB, so I'm saying this bottom length over this top length, must be the same as CE over EB. So on the other side of the triangle, this bottom length over this top length. So notice a couple of things. The numerators are both the bottom portions of the triangle, and the bottom of it is both the top of the triangle. Now you could write that completely upside down of DB over AD equals EB over CE, and that's absolutely fine. Now, of course, as always, there are many ways to write the same stuff. If I wrote it as a proportion of the bottom two lengths, so AD over CE, that would be the same as the top two lengths, so DB over EB. So I want you to notice something. Across from each other is exactly the same information, and across from each other on the other side is the exact same information. It just depends on how do you see it. Do you want to do a ratio that each ratio is its own side, so they are their own side? Or do you want to write a ratio of the same part of each side? So like these ones are the same part, they're both the bottom parts of that side. Whatever makes the most sense to you and whatever fits best in your brain is the way that you're going to do this. Okay, so let's use this one. We have this lovely triangle and we have these two parallel sides. So I'm trying to find the missing side, and I'm going to make a ratio of 14 over 12. So I'm choosing to use ratios of the same side, equals, now my other one has to start with x. If I started with 14, my other ratio has to start with x, and over 15. And we cross multiply to figure out our answer. So first of all, 14 times 15, if I were to cross multiply, is 210. And that equals 12x. And if I divide 210 by 12, I end up with x equals 17.5. So I have just found the missing side of my triangle. If I had chosen to do 14 over x, so I'm doing a ratio of that same part equals 12 over 15, I would still get the exact same answer. So I'd end up with 210 equals 12x, and I would still equal x equals 17.5. Again, the one that works best in your brain is the one that you are going to use. Okay, let's try another one. So on this triangle, I again have my two parallel parts. And that means that that parallel line cut those sides into proportional lengths. So I'm going to write it as x minus 1 to 3x plus 1. And that's going to be the same as, so I use the same side, 6 to 21. So since I started with x minus 1 on the top, I had to start with 6 on the top of my other ratio. If I cross multiply, I'm going to get 21x minus 21, I'm just distributing as I go, equals 18x plus 6. I'm going to subtract 18x from both sides. I'm going to get 3x. Oh, I'm also just going to add 21 right now. 3x equals 27. And if I divide 27 by 3, I get x equals 9. So if I wanted to find my two side lengths, x minus 1 is going to become 9 minus 1, so that is 8. And 3x plus 1 would be 3 times 9 plus 1, so that's 27 plus 1, which is 28. So there are my two side lengths. If I just needed to find x, I found x equals 9. Now there's another similar theorem to this that also creates proportional lengths. It is the triangle angle bisector theorem. So if you have an angle bisector that bisector, it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So what this is saying is, here's our angle bisector. If I were to write a ratio of A to D, so that's one of the sides that the angle bisector cuts in pieces, to AB, so that and its companion side, would be the same as DC, which is this one right here, that other one that the angle bisector cut, and its proportional side, so BC. It's kind of like it cuts it into two triangles, and those two triangles are proportional to each other. So you can write proportions with an angle bisector also. So let's try this. So here's our angle bisector. If I made a ratio of 12 to 18, so that is the side that was cut to its companion side, that would be the same as X, so the side that was cut, to 24. If I cross multiplied, I would have 18x equals, and 12 times 24 is 288. And if I divided both sides by 18, I would get 16. So that means that my missing side is 16. Okay, let's try one more. So here's my angle bisector. If I were to write a ratio of the side that is cut by the angle bisector to its companion side, and that's next side to its companion side would be 6 over x plus 7. So making sure that the side that is cut by the angle bisector is in the same part of our fraction, okay? If I were to cross multiply, 6 times 10 is 60. 5 times x plus 7 is 5x plus 35. I would subtract 35 from both sides, so I'd get 25 equals 5x. Divide both sides by 5, and x equals 5, which means our missing side over here is 5 plus 7, 12. So you can use proportions to find missing sides of triangles if you are given a parallel line within the triangle, or if you are given an angle bisector.